The topic deals with waste management, which is not, I think, the most sexiest topic or most glamorous topic, but it is quite important. So it doesn't matter how sustainable a city is or how smart it is. There's still some basic services that a city has to deliver to its residents. So these include providing water to residents, electricity, sanitation, and then the last one is waste collection. So there's also a bunch of other services, but why I wanted to focus on these ones is because we tend to only appreciate them when they're not there anymore. We tend to take them for granted, but once they're not there, then people start to get mad and angry. So as a case in point, I'm just quickly going to go to Lebanon in Beirut. So this was Lebanon, June 2015, quite a pretty place, a nice place to hang around in. And in June, Lebanon's landfill site closed down. It just closed down. No alternative was made, so Lebanon couldn't collect waste anymore. They just stopped collecting waste in the city. So this is what happens about 2 months later. The waste just started to pile up on the side of the streets in huge quantities. And this was 8 months later. So a 3-kilometer river of waste actually formed leading outside the city because they just had no way to actually get rid of the waste. This led to protest actions because waste was not being collected. So about 100,000 Lebanese people actually took to the streets and demanded the resignation of the current government because they weren't providing one basic service. Which is waste collection. So this was almost enough to topple over the government. I'm still following this news story. I think they're now at a point where they're actually dumping the waste into the sea because they don't have a safe and disposable or safe way of actually disposing waste. So waste is important, and again, it's important to make it sustainable, to try and deliver this service as best as possible. So part of waste collection is to analyze waste collection, you first have to appreciate the scale at which it's actually performed. So from a residential perspective, we tend to forget about waste the moment it leaves our house. Then a truck comes around, picks it up, and then it disappears. Then it's out of our mind. But again, from a city's perspective, it looks quite different. So the city of Cape Town, they have to service over 1 million people every week. They have to go out and collect the waste of 1 million people. And they do this with about 200 waste vehicles. So every day in the city, there's 200 vehicles just driving around all over the city. So these are the actual vehicles. And you can sort of see how they're picking up waste at each and every resident in that city. So the scale at which it performs is actually massive. And with the scale at which it's performed, which is massive, this means a lot of money goes into actually, I think Lebanon wish they could do this, but a lot of money goes into actually just taking care of our waste. So this is a report by Treasury in 2011, and annually South Africa spent about 7.3 billion rand just getting rid of waste, of which, that's about, using today's currency, that's about 500 million euros. So this is money that's being spent not creating value or anything. It's literally just spending money to get rid of something. Ideally, you would want to spend the 7 billion on building schools or building hospitals. You do not want to spend it on moving waste around. There's no value in doing that. So for the actual collection and transportation, so this is just the trucks driving around with waste on them, that costs about 3.3 billion rand. In South Africa. Again, 2011, so this prices have went up over the years. So this is how much money cities are spending just driving around with waste on them. I'm taking it from residential areas to landfill sites. So our whole perspective is, as industrial engineers, is we need to reduce the cost that's being spent on waste collection in any way possible. Municipalities don't have a lot of money, so if you can save money on waste collection, that means there's money to spend on somewhere else, which is a better way to spend it. Again, hospitals or schools. So even a 10% reduction in waste collection cost, that's 300 million rand per annum that you can spend on something that's actually useful. So this is what we're trying to achieve. We're trying to figure out ways of better managing waste and optimizing the waste collection process. Okay, so there's a lot of different ways that you can actually optimize the waste collection process. It's a well-researched area. So one of them, which is my area of expertise, is just to develop better routes that the vehicles follow. So on the left, we have an inefficient route. On the right, we have a vehicle that's servicing the same area, and it's an improved route. So you just change the operations of the vehicle, and by doing that, the vehicle travels less. It spends less time collecting, so you can service more areas, and by doing something simple like that, you actually save a lot of money. So again, well-researched area, we've published in it, a bunch of other researchers have published in it. So in that review, they looked at about 67 different papers, just focusing on models that you can use to optimize waste collection. There's just one problem with all this research, including our own research, and that is we all assume that the data that you need for these models are readily available. This is a prerequisite for those models, which in developing countries is simply not the case. The data is not available. Just to put it in perspective, if you want to do waste collection routing optimization, you then, for each street in that area, you need to know how long it takes a vehicle to service that area, the time to travel through that area, the service direction of that street, the amount of waste generated on that street, the carry capacity of the vehicles, and working hours of the collection crew. So that's the data that you need on a street segment level to actually do proper vehicle routing. And you need this data on an entire city. And that data is simply not available. Fine. And we found this out the hard way. We went to municipalities, asked them, can we improve your waste collection routes? They say yes, and we asked them, can we get the data? And they're like, what are you asking for? This doesn't exist. It's not feasible to actually do this. So in order to do waste optimization, you can't just go to the optimization models. You first need to figure out a way of getting the data that you can then plug into these models. And this is what this talk is about. Is that we think we've found a cost-effective way to actually get very detailed waste collection data from municipalities and using readily available data sources, which are cheap and scalable. Okay, so the steps to improving waste collection is, again, we learned this the hard way, is you can't start with the optimization model. You first have to start with the descriptive model. You first have to describe what's currently going on in the waste collection process. So descriptive models just describe what has occurred, and they describe how a system or process currently operates, and they're useful for identify business opportunities or improvement opportunities. So this is where you need to start. You first need to figure out what's being done. And there's also a saying which doesn't get measured, doesn't get done. So this is really important. So this has been our focus area, is to just focus on descriptive model, to develop a very good descriptive model of waste collection in a city. Once you have the descriptive model, then you can go to a predictive model. So you can then predict what will happen. So we usually just extend the descriptive model, and then you can see, okay, what happens if more people in the area? What happens if you change service route? So then you can go towards a predictive model. And once you have the predictive model, then you can go to the prescriptive model. So this is where the actual optimization goes. So if you can predict how a system will behave, then we can actually develop a model to tell us what the system should look like, in order to optimize the system, to reduce cost or increase service delivery. Again, and there's a natural progression with this model. So we just start with the model to figure out what's going on, then we extend that to a predictive model to predict what will happen, and then we can go to that optimization model. And at the end, this is where municipalities will save money, once they can actually optimize their system. Okay, so our whole emphasis so far has been on developing a descriptive model for waste management. Okay, so data that we do have available. Readily available is GPS records of waste collection vehicles. Most collection vehicles has a sensor in it, just for quality purposes, that actually sends the location of that vehicle. So this is a readily available data source. And again, this video is just based on that data source. So what it actually looks like is you have this huge file. So in this case, we got data from the city of Cape Town. So we have GPS records of 787 vehicles from January 2013 to September 2014. So that's about 50 million records. And each record has a vehicle registration number attached to it, a timestamp, and an X and Y coordinate. So this is data that's available. It's out there, and most municipalities is actually generating it. So the challenge that we set ourselves is how well can we analyze waste collection and transportation using just the vehicle GPS records? This is what we set ourselves out to do, our challenge that we set ourselves. Okay, so how we process this data is we have the raw data, so we then use Python and R to convert that into SQL-like database, just to make it easier to run queries. And now we're using the database again with R just to do analysis. So I'm just going to share the analysis that we've done so far. Okay, so the nice thing about the GPS records is you can visualize it, and just by visualizing the GPS records, you can actually infer a lot about what's going on in waste collection. So this is a year's worth of GPS records for a single vehicle, and you can immediately see where this vehicle is actually servicing. So you can literally see the household's outline just by seeing where that vehicle is actually collecting waste. So I think these pictures are pretty. I don't know, maybe I'm weird in that sense. But just looking at the GPS records, you get a sense of what this vehicle is doing. Is it collecting waste? Yes, it seems like it's collecting residential waste. So this is another vehicle. And again, this one is a bit easier to analyze because with this, we can actually see where this vehicle is collecting waste. In this case, it's collecting waste there in that bottom corner. In the left corner over there, we can see there's a high density of points. So that's where it's actually picking up waste. Again, just by looking at the GPS records, we can actually infer what's going on. And at top, it seems that the vehicle is spending a lot of time there. So we'll probably guess that's actually a landfill site. So we can immediately guess that the vehicle is collecting there and offloading there by just looking at the actual GPS traces. This is the GPS traces of another vehicle. Here we can't identify a residential area, which means this is probably a bulk collection vehicle. So that vehicle goes from point to point to point to collect waste. It doesn't service residential areas. So we would analyze this vehicle different than we would analyze a residential waste collection. Again, just by looking at it, we can actually see what the purpose of these vehicles are without really using any additional information.
This is over a year per vehicle?
Yeah, over a year per vehicle. Okay, not all the records are clean. There's some errors. So Cape Town is quite windy. It looks like the GPS records are actually being blown away for some reason. So there are errors in the data, but because we have such a big source of data, we can actually just exclude them. We don't have to try and fix it. We can just focus on the easy data that has to be analyzed. This is another vehicle, maybe a waste collection plane, if such a thing exists. I doubt it, but this is also, again, we can ignore this. We have enough data to work with that we can just focus on the good data and see what we can actually extract from that. So that's just the visualization. So what we've now tried to do is to actually take those records to identify when vehicles are servicing and when we're just traveling in general. And here we actually trace the speed that the vehicle is traveling at and its location. And there the assumption is the vehicle is traveling slowly, it's collecting waste. If it's traveling really fast, then it's not collecting waste because you have a collection crew that has to walk with it. So by just doing that analysis, we can see that this vehicle probably served those black little areas. So we know exactly where this vehicle actually picked up waste. Again, by just looking at the actual GPS records. Okay, so the idea is then to use this data and then analyze how well waste collection is actually being done. So the previous slides had a vehicle focus. So what we've now moved to a service area perspective. So instead of analyzing vehicles, let's analyze a service area and see how the vehicles operate in that service area. A data source that we have available is waste collection beats. So this is publicly available. So these are waste collection beats. And the idea with the waste collection beats is that it is a geographical boundary and one vehicle services that beat. And it should be able to service that beat in a day. And then these beats are allocated to different collection days. So some of these beats will be Monday, another's Tuesday, Wednesdays, Thursday, Fridays, and so forth. So in this case, we're at the moment looking at the top beat, which is highlighted in red because it's easier to analyze. So we can now look at, okay, how does the GPS records look inside that actual beat? So this is all the records in that actual beat. And again, you can see how they match with the street network. So we know the vehicle is collecting waste in that beat. So what we then did is we said, okay, but on which day of the week is that beat being serviced? So all we did is we looked at the vehicle records on Monday, there's nothing. On Tuesday, there's a lot. Wednesday, there's nothing. Thursday, nothing. Friday, nothing. Saturday, there's nothing. Sunday, nothing. So we know the service day of that beat is on a Tuesday. So we know we only have to look at Tuesdays if you want to understand how waste collection is actually occurring. So now we can look at a single day's waste collection in that beat. And now we looked at, okay, what vehicles are actually traveling through that beat. So they're color-coded here, and we see there's about, on one service day, there's about 4 vehicles that travel through that beat. But number 285 is a predominant one. So now we know that beat is being serviced on Tuesdays, and on this Tuesday, it was serviced by vehicle 285. So now we can go back and say, okay, but how did vehicle 285 move throughout the day? So this is the travel of vehicle 285 in that day, and then we can clearly see vehicle 285 services that beat on that day, and only that beat. Again, and now we can actually see how well does that vehicle service that beat. So again, information that we have available, we know that's a landfill site, publicly available data, and we know that's a vehicle depot. So the next, what we can do is we now need to split that route of the vehicle to see, okay, when did it service that area? When did it go to the landfill? When did it do nothing? And all we did is we then actually see on that day how far was that vehicle away from the landfill site. So looking at this is pretty useful. So we know where the depot is, and then we see it travels, and then it stays constant within that beat, and then it made a landfill site visit. So it offloaded waste. And then it went back to that service area, serviced it, and then it went back to the landfill site. And again, then it went back to the depot. So in this case, we know exactly at what time that vehicle serviced that area. We know when it visited a landfill site. And in this case, we know that that area has more than one truckload worth of waste on it. So we can actually start to guess how much waste is in that area. So this just shows the speed of that vehicle. Again, you can see it travels slowly when it's collecting waste. It travels very quickly when it's actually going to the landfill site. Okay, so, and this is the total distance traveled by that vehicle. So we can see the vehicles travels a far distance until they get to their collection area. Then they travel slowly. They don't travel that fast. And then there's another jump when it goes to the landfill site and back to the collection area. And then again, it travels slowly. So this information is handy because now we can quantify waste collection. We can actually draw KPIs to see how well waste collection is being performed. So what we did using the previous one is we're calculating the distance and travel time for that service area. So this is the service distance traveled. So all we need to do is we just need to calculate, okay, how much distance did it travel in that area and versus the total area. So there's the distance in red versus the distance in black. And again, because we can automate this, we can then calculate this for the entire vehicle over a year horizon, in this case 6 months. So we know within that waste collection beat, it typically takes between 4 and 8 hours to actually service that area. And we can check, okay, on one day no service occurred, maybe a strike or something. And we can actually then see, okay, but how much of this time was spent collecting waste and how much was spent just driving around between the different areas. And here we see that when the vehicle spends about 8 hours, it only spends about 5 hours actually collecting waste. The rest of the time is traveling between different points. So we can do the same with total distance travel. So this vehicle travels between 60 and 90 kilometers per day to service that area. And then the actual service distance is not that much, between 15 and 20 kilometers. And again, we can do this now for that service area. And where the fun comes in is we can now actually calculate how much that costs. So using basic assumptions, so let's assume that it costs 20 Rand per kilometer to operate that waste vehicle, and that the time is 220 Rand per hour for the waste crew. Now we can actually calculate how much the service area costs to service per service day. And here we see it's between 2,000 and 3,000 days typically to service that service area. And then of that, the actual collection of the waste is between 1,000 and 1,500 Rand. The rest is just about driving around. So this is what we can actually get just out of the raw GPS records. Okay, so I'll wrap up quickly just with future work. So what we're going to do next is we're going to repeat the analysis for all areas. So the idea is that you get to this map. where for the whole city, you can actually see exactly how much each waste collection beat cost. And then you can identify high cost areas versus low cost areas, and you can target the high cost areas for improvement. And you can do this for benchmarking. Why is this area more expensive than the previous one? And government can use that even for fraud purposes. Why is a contractor quoting us 10,000 Rand per service area where we know it should have only costing them 3,000 once we have this? So what we're also going to do, we want to add more data. So the big one we have is we have a synthetic population, which is individuals. Detailed data on individuals, where they're located for each and every beat. And then we know the household side, employment and income. So we can calculate, okay, these are high income people. How much are high income people costing the municipality to service versus low income people? Okay, and then another one is we want to add the weighbridge data. So we know it offloaded waste there. So in this case, we know that's linked to a weighbridge record. So the weight that equals, so then we can know exactly how much waste was actually being collected in that area. Other thing what we're doing, we're actually removing data sources because this data sources won't be available for all municipalities. So specifically, if we don't have accurate beats, what can we do? So we're there looking at clustering algorithms to identify service areas using just the GPS records. And then the last step is we want to move from service areas to street segments. So we're going to use map matching, then we can actually see exactly how fast the vehicle traveled. And then the idea is that you actually have this information per street segment. And that is information that you need per service segment. Okay, so the benefits of this approach is we're using existing data sources that's ready to be available. We're not, it won't cost more money to get this data. It's a bottom-up approach. We're starting on a very small scale, so we can aggregate upwards. You can't aggregate downwards. Once you have big data, it's possible to aggregate downwards. And then it's automated. This runs via R, and therefore it's scalable. So if you do it for one metro, then we can do it for other one. It's easy to maintain. As the GPS records come in, you can just maintain this. Some of the challenges is that big one is the GPS records are not owned by municipalities. They are owned by service providers, which track the vehicle. So typically, a municipality has to buy their own GPS records back from the service provider, if they're willing to sell it to them. Sometimes they just say, no, you're not getting your records back. Another disadvantage is there's many role players. This is a disadvantage because we don't always get a champion to sort of drive this, to say, okay, I will drive this, I will pay for this. And then there's also a lot of resistance against being measured on a micro scale, especially for the waste collectors. We're afraid this might actually cause them to strike. They don't want to be measured on that level. So the way forward is we want to get buy-in from other cities and waste operations so that we can actually start comparing different cities with each other to see how they're performing. And then to collaborate with other and more traditional waste management researchers. We think this can really supplement their work, which we do more on a case study basis, so they can then extrapolate the results, and then to continuously refine and test the models. Okay, so that's where we're heading. So back to the original research question, how well can we analyze waste collection using GPS records? I think the answer is pretty well. We can actually analyze it pretty well using just a single source of data. Okay, thank you very much. Yeah, any questions?